Hi, welcome to today's lesson on differential equation. This is the last topic of the chapter on integration and focuses on only the first order differential equations using the method of separation, so stay tuned. Okay, so we're going to start off with a very basic example. So let's say dy dx equals to a constant 3. The solution to this differential equation is basically to find out what y is as a function of x. When you differentiate that with respect to x, you get the number 3. We know the solution to this equation, so basically we get y equals to 3x plus c, where c is called the constant of integration. Okay, so I'm just going to go through the process of separation of variables with this example, but then I will explain it in more detail later on. So dy dx is seen as dy divided by dx. So we're going to move the dx over to the other side and multiply. So we get dy equals to 3 times dx. And then we now integrate both sides. Now on the left side, the integration is done with respect to y. So what is integrated here is the number 1. So 1 is integrated with respect to y on the left side. And on the right side, the number 3 is integrated with respect to x. So when you integrate 1 with respect to y, we get y. And when you integrate 3 with respect to x, we get 3x plus a constant of integration. You might be asking, hang on, how comes we didn't get a constant on the left side when we integrated and we only got constant on the right hand side? Well, technically you do have constant on both sides, but if we get constant on the left side and then we move the constant to the right hand side and bunch all the constants together and then we call it a plus c, this is now the overall constant is now plus c, so there's no need to write constant on either side. Okay, now this solution is called the general solution. Why is it called general solution? Because it gives you an infinite number of solutions depending on what that value of c is. So if we were to sketch some of those solutions, so for example, if c is equal to 0 here, we will get y equals to 3x. In other words, it will be a straight line going through the origin where the gradient is equal to 3. If we have a parallel line to that where it intersects y-axis at 1, in other words, c equals to 1. Or if we get another parallel line that intersects the y-axis at 2, c would be equal to 2. Or 1 below, if that's equal to minus 2 here, then this will be c equals to minus 2, etc. So in other words, we will get an infinite number of parallel lines, all of them having the gradient 3 in common. And this is said to be a family of solution curves. This is called the family of solution curves to this differential equation. Okay, but what if you were asked to find only one of those solutions? Okay, so in that case, we need to be given some boundary conditions in order to work out what that c is. So if we're given that when x equals to 3, maybe y is equal to 10, then in that case substitute those into the equation above, or the solution to our general solution. We get 10 equals to 3 times 3 plus c, or 10 equals to 9 plus c. That gives you c is equal to 1. Therefore, we get a solution as y equals to 3x plus 1. And this is now called the particular solution to this differential equation. Let's put some steps into our method of separation of variables. So I want you to write those steps down as I go through them, and we're going to apply those steps in the example that will follow up. Okay, so step 1 is to write dy dx equals to a function of x times a function of y. So the left side, you need to have a single term, or in other words, a single fraction. And the right side also needs to be a single term, or if it's a fraction, then a single fraction. Once you have that in that form, step 2 is to separate the x and the y. So you want the y's to be on the left hand side and the x's to be on the right hand side, but only using multiplication and division. Those are the only two operations you're allowed to use in order to separate your variables x and y. Hence, it's called the method of separation. Step 3 is to integrate both sides. And step 4 is to write what y is as a function of x if required. Some questions will ask you to make y the subject, and if it doesn't, then once you've integrated, you can leave the answer as it is. Once you do that, this is called the general solution to your differential equation. Okay, but what if you're given boundary conditions? So you need to work out what that constant c is. You need to obviously substitute that into your solution. The sooner you substitute your boundary condition in, the easier the working out will be. So the earliest point you can substitute your boundary condition is obviously after you have integrated. You will need to substitute in your boundary conditions to find what that constant c is. And then you simplify the answer and you write down what y is as a function of x. Here we have 3 further basic examples on differential equations. So if you look at the first one, we have dy dx equal to x. The left side is a single fraction, the right side is a single term. So in other words, the first step is already done for us. Step 2 is to separate the variables only using multiplication and division. So on the right hand side, we already have the x on the right hand side. So we need to move that dx across to the right hand side. So we would get dy equals to x multiplied by dx. So variables are now separated. Step 3 is to integrate both sides. Here we have a constant 1 at the front, so we integrate 1 with respect to y. On the right hand side, we integrate x with respect to x. So the left hand side just gives us y equals to the right hand side, we'll get x squared divided by 2 or multiplied by half plus the constant of integration. And we have the general solution to this equation. So here we have dy dx is equal to y. So the first step has already been done for us. So we have a single fraction on the left hand side, single term on the right hand side. We only want x's on the right hand side, so we need to move that y across to the left hand side, but only using multiplication or division. In this case, we're going to use division. So if we were to divide both sides by y, well, y divided by y is equal to 1. And on the left hand side, if you divide by y, that's the same as multiplying by 1 over y, and we'll have dy by dx. We now move the dx across to the other side, and this time we're going to multiply. So we have 1 over y dy equals to 1 times dx. Now that we have the variables separated, step 3 is to integrate both sides of the equation. So on the left hand side, we integrate 1 over y with respect to y. This will give you ln of y equals to integrate 1 with respect to x gives you x plus a constant of integration. So here 1 over y integrates into ln y. And the last step is to write what y is as a function of x. So in order to cancel off the ln, we have to raise both sides to the power of e. So if we have e to the power of ln y, this will be equal to e to the power of x plus c. E and ln cancel out and we get y equals. Here we can rewrite this as e to the x multiplied by e to the power c using the power law. C is a constant, e to the c is a constant. We can redefine that constant, call that capital A. So therefore my solution for this one will be y equals to the constant A multiplied by e to the power of x. Now this is the general solution to this differential equation. Third example, dy dx equals to x times y. Again, single fraction on the left, single term on the right hand side. Step 1 is already done for us. So we can now separate the variables using multiplication and division. So let's start with the y on the right hand side. This is multiplying on the right hand side. So if we divide both sides by y to get the y on the left hand side, so we'll get 1 over y dy by dx equals to x. And then we want to move the dx across to the other side, and by multiplying we have 1 over y dy equals to x dx. And now we can integrate both sides. This will again give us ln y equals to a half x squared plus c. and then e both sides, so y equals to e to the power of a half x squared plus c, which can also be written as e to the a half x squared times by e to the power c using the power law, and this can be redefined as constant a. Y is therefore equal to a times e to the power of a half x squared, and this is the general solution to this equation. Okay, so in this example we have dy dx equals to x times y plus y. So the left side is a single fraction, but the right side is not a single term. There's two terms on the right hand side, so we have to get the right hand side into a single term first before we can separate the variables. So in order to get this as a single term, we need to factorize the y out, so y bracket x plus 1. We now have a single term on the right hand side. So this is step 1 done first. Now for step 2, we are now ready to separate the variables. The x plus 1 can stay where it is, so on the right hand side we need to move the y to the left hand side. So here is multiplying the bracket, so we're going to divide by y on the left hand side, same as multiplying by 1 over y. So you get 1 over y dy dx equals to x plus 1. Okay, so brackets are no longer needed, but I'm just going to keep them there for now. And then move the dx across by multiplying, so we have 1 over y dy equals to bracket x plus 1 multiplied by dx. We can now see that the bracket is actually needed because we're multiplying both terms by dx. Step 3 is to integrate both sides. Now integrate 1 over y gives you ln of y equals to integrate 1 plus x gives you a half x squared plus x plus a constant of integration. And then we e both sides, so we get y equals to e to the power of a half x squared plus x plus c. And just like before, using the power law, this is the same as e to the power of a half x squared plus x. I'm going to leave the half x squared plus x as a power of e, but the plus c here, I'm going to rewrite that as multiplied by e to the power of c. Remember that when you times a base number with the same base number, the rule is to add the powers, which will go back into there, but we're just undoing that power law to split up the indices. And we're just going to redefine that e to the c as a constant a. Therefore, our y is now equal to a multiplied by e to the power of a half x squared plus x. And this is the general solution to this differential equation. So a differential equation doesn't necessarily have to be in terms of x and y. Here we have it in terms of z and t. So z is the dependent variable and t is the independent variable. If you recall, step 1 is to get the differentiation of z with respect to t, the subject here of this equation. So in order to do that, we have to move the plus 9z across to the other side, and all we can do this is through subtraction. And remember, we are not applying the separation of variables just yet. Step 2 is to separate the variable, but only after both sides are written as a single term. So if we move that term across to the right hand side, we will have dz by dt equals to minus 9z. We are now ready to separate the variables because we have a single term on the left side and a single term on the right hand side. The left hand side has dz on the top, so everything on the left hand side needs to be in terms of z, and everything on the right hand side will be in terms of t. Okay, so in other words, z here is playing the role as y and t is playing the role as x. So on the right hand side, we can either move the z to the left hand side, or we can move the whole of the minus 9z across to the other side. But I'm just going to pick that and leave the minus 9 where it is and move that z across to the other side, and obviously we need to perform division. So on the left hand side we now have 1 over z multiplied by dz by dt equals to minus 9. We now need to move the dt across to the other side by multiplying. So we have 1 over z dz equals to minus 9 times dt. So that's step 2 done. Variables are separated. Step 3 is to integrate both sides. If we integrate 1 over z with respect to z, that gives you ln of z equals to minus 9 with respect to t, it gives you minus 9t plus your constant of integration. We have ln z, e both sides to get z by itself. This would be e to the power of 9 minus 9t plus c. And just like before, we can rewrite this as e to the minus 9t times by e to the power c. We define that constant as a. So in other words, z equals to a e to the power of minus 9t, and we have our general solution.